All right, so we are going to graph this rational function. We can see that it's a little different than the other ones we were doing, where the degree in the numerator is larger than the degree in the denominator. And when we see that, we should be thinking slant asymptote or oblique asymptote. But before we do that, I always like to start off with our vertical asymptotes. They are nice and easy to identify. It's already factored for us, so we do not need to worry about any factoring or any removable discontinuities. Vertical asymptotes come from where your denominator is equal to 0. So 0 equals x minus 4. So x equals 4. So over to my graph, x equals 4, a nice vertical asymptote. Again, its multiplicity 1. Its degree is odd, so I know that around the vertical asymptote, we are going to be going in opposite directions, not the same direction. And I suppose we'll tackle this slant asymptote. So horizontal asymptote, again, you can do long division or you can do synthetic division. I am a fan of synthetic division when I can use it. If this was not a nice factor like x minus 4, then I would choose to be doing long division. So 2 for the x squared term, 0 for the placeholder of x, and 3 for our constant. So carry down that 2, multiply, multiply, and add. That is quite a remainder there with 35. So let me just double check that. So to carry down the 2, multiply, add. No, that's good. So our function is now 2x plus 8 plus 35 over x minus 4. And so for our our horizontal asymptote, we are going to follow 2x plus 8. So I'm going to come over here to our graph and maybe zoom in a little bit. So 2x plus 8 we are going to be following. So that means that I probably want to increase the y-axis a little bit so that I can mark a y-intercept of 8. So it's going to be quite a steep oblique asymptote. So I'm at 4, 5, 6, 7, 8. So there is my y-intercept right there. And then I am just going to do a rough sketch for our oblique asymptote and a dotted line for this. So we are going to be following this slant asymptote out to infinity and out to negative infinity. So we are going to have to follow that out. So it's pretty steep there. And so there is the vertical asymptote and the horizontal asymptote. Again, it's a rough sketch. It's not beautiful. So let's take a look at our, let's do our x-intercepts. So x-intercepts, oops, let's do a different color there. Let's go with black. So x-intercepts happen where y is equal to 0. And remember, we just need to take our numerator, so 2x squared plus 3. So where 2x squared plus 3 is equal to 0. So let's see what we get here. Negative 3 halves plus or minus a square root. Plus or minus the square root of negative 3 halves. If you subtract over that 3 and then divide by 2, and then take the square root. So we have no real zeros here. They're all complex. So we have no real. So let's take a look at y-intercepts. So we have nothing to add to our graph from there. Let's take a look at y-intercepts. So that happens when x is 0. So if I scroll up a little bit, we're going to have 2 times 0 squared plus 3 all over 0 minus 4. So I suppose I can write that down. So 2 times 0 squared plus 3 all over 0 minus 4. So that will give us negative 3/4 for our y-intercept. So negative 3/4 is going to fall somewhere before -1. Do your best to sketch it. Doesn't have to be beautiful. And that is all we are going to need, I believe. Let's see if we can't do this. So I'm going to bring up that vertical asymptote to match my horizontal asymptote. So all the way up here. Ooh, that got a little slanted. So let's fix that just a little bit. Just so I can keep everything straight, that I do need to get all the way up there. And so I cannot cross the x-axis at all. I have no x-intercepts to cross the x-axis. I know I have to follow this slant asymptote, and I need to follow the vertical asymptote. So if I have to do that, and I have to hit this y-intercept, what's going to happen is I'm going to come up, hit that y-intercept, and then come back down to match the vertical asymptote and follow that vertical asymptote down to negative infinity. And then I know that I have to be in the opposite direction on the other side of the vertical asymptote. So that means, let's see, I'm going to scroll this out a little bit. And I'm going to again extend my vertical asymptote up and extend my oblique asymptote out. I'm going to erase where I thought that arrow should go and put it where it now is going. So I need to be on the other side of this vertical asymptote, and I need to follow this horizontal asymptote. I can't cross the x-axis anywhere. So what's going to end up happening is quite interesting. It's just going to be up here and do this little kind of odd parabola shape. It's just going to follow both the vertical and the slant asymptote. Let's see if I can't clean that up a little bit. All right, so if I made this a little clearer, so this is just going to be very, very rough sketch. It's just going to be a very rough sketch. So at 4, I have that vertical asymptote. So what's happening is basically I'm getting this type of shape. So I'm getting this kind of awkward upside down parabola, and then I'm getting this shape right here up in the corner. So it's pretty interesting. Let's zoom back to that more accurate graph that we have right here. And so the slant asymptote definitely controlled this graph for us. So it's important that we find that slant asymptote when making a more accurate sketch.